On section 1 of the Piktochart, we had to find the work for the Lamborghini versus the Honda Civic, and to find work would be force times distance. So we found the force, which is the mass times acceleration, and we found that the mass was 1,100 of the Lambo, and we had to multiply it by the max acceleration, and we got 6,776. So we plugged that into the work equation and multiplied that by 1,000, which is the distance, and we got 6,776,000 joules. And then on the Honda Civic, we had to do the same thing. So we found the force, 2.66 was the max acceleration, so we multiplied that by the mass, which is 1,179, and we got 3,136.14. And then we plugged that into the work equation and multiplied that by 1,000, which is the distance, and got 3,136,140 joules of work. And
Okay, so for section 2 is kinetic energy. So for the Lambo, you have to multiply 1/2 times the mass, which is 1,100, times the velocity squared, which is 91.2. And then for that, we got 4,574,592 joules. And then for the Honda Civic, we calculated 1/2 times the mass, which is 1,179, times 56.3 squared, which is the velocity. And then we got 1,868,532 joules.
for section 3, we had to calculate potential energy. And for the Lamborghini, the equation was mass times gravity times height. So 1,100 was the mass, 9.8 is gravity, and our height was 212. So we multiplied all three of those together and got 2,285,360 joules. For the Honda, our mass was 1,179, gravity is always the same, 9.8, and the height was the same of 212. And when we multiplied all three together, we got 2,449,490.4 joules.
Okay, so for the first equation, we had to calculate how much force the brakes had to use to stop the vehicle going to max velocity. So for the Lambo, we did force equals KE2 minus KE1 divided by distance, which the KE2 is 0, minus 457,592, which is KE1, divided by the distance, 34.7, which equals negative 131,832.62 joules. And then also for the second equation, we had to see how like each car lifted to 22 meters. For the equation, it was force equals PE minus KE1 divided by distance, which was 237 point, oh fuck, okay. Okay, 237,160 minus 400. I can't say it. I can't. I know.
4,574,592 divided by 34.7, and the force equaled 105,327.378 newtons.
And then for the force for the other equation equals 0 minus 1,868,532.25 divided by 37.5, and that equaled negative 49,827.52 joules. And then for the second one, we did 254,192.4 minus 1,868,532.25 divided by 37.5, and that equaled 204,300.
Oh yeah, you're right.
364.873 newtons.
Okay, for this section we had to find power, which is work divided by time. And for the Lambo, the work was 6,776,000 joules divided by 14.81 seconds, and that got us 457,528.6968 watts. For the Honda, it was same power, was work divided by time. So the work was 3,186,140, joules divided by 21.17 seconds, and we got 148,140.7682 watts. For the second part of the section, we had to find how many 100-watt light bulbs each car would carry. For the Lambo, we had to do 457,528.6968 watts divided by 100, which got us 4,575.28696 100-watt light bulbs. For the Honda, we did 148,140.7682 watts divided by 100. We got 1,481.407682 100-watt light bulbs.